It is given the next information. This question asks you to investigate regular n-sided polygons inscribed and circumscribed in a circle and the perimeter of these as n tends to infinity to make an approximation for point A. Consider an equilateral triangle ABC of side lengths x units inscribed in a circle of radius 1 unit and center O as shown in the following diagram. So it is given a circle of radius 1 and center O, and ABC is an equilateral triangle inscribed in this circle and each side is equal to x. The equilateral triangle ABC can be divided into three smaller isosceles triangles, each subtending an angle of 2 pi over 3 at O as shown in the following diagram. COB, CO is 1, OB is 1, BC is x, and the angle is 2 pi over 3. Using right angle trigonometry or otherwise, shows that the perimeter of the equilateral triangle ABC is equal to 3 root 3 unit 3 marks. Perimeter is 3x. X can be found from triangle BOC, and we can apply, for example, cosine rule. Formula is given in a data booklet, and it says that x squared is 1 squared plus 1 squared minus 2 multiplied by 1 and by cosine of 2 pi over 3. Cosine of 2 pi over 3 is -1/2, so it becomes 1 plus 1 plus 1, so it's 3. So x is root 3 and the required perimeter becomes 3x, which is 3 root 3 as required. B. Consider square of side lengths x units inscribed in a circle of radius 1 unit. By dividing the inscribed square into 4 isosceles triangles, find the exact perimeter of the inscribed square. 3 marks. So we should consider a circle and a square inscribed in a given circle A, B, C, D, and we should consider 4 equal isosceles triangles, and each side is x. And let's consider, for example, a triangle AOD. AO is radius and DO is also radius, so AO is DO is 1, and applying the Pythagoras theorem, x squared is 1 squared plus 1 squared, so x is root 2, so perimeter is 4x, so it's 4 root 2 units. Or you may consider right angle triangle AOD, and using an angle pi over 4, and we can consider sine or cosine and find x, or it may be used just the Pythagoras theorem for a given right angle triangle. The next, C. Find the perimeter of a regular hexagon of side lengths x units inscribed in a circle of radius 1 unit 2 marks. So we should consider hexagon inscribed in a circle. And if we consider one triangle AOB, it's an isosceles triangle in general if we consider some n-sided polygon, but since AOB is 60 degrees, triangle AOB is an isosceles. Yes, in general it's isosceles for any n-sided polygon, but for regular hexagon it's an equilateral triangle. So we can say that AOB is an equilateral triangle, and AO is radius, OB is radius is 1, and OB is 1, and each side is x, so x is just 1, so perimeter is 6. The next, let pi of n represent the perimeter of any n-sided regular polygon inscribed in a circle of radius 1 unit. D shows that pi of n is 2n sine over pi over n 3 marks. So now we should consider a regular n-sided polygon inscribed in a circle radius 1, and again let's consider one triangle. Side is x, radius is 1, and this angle AOB it's 2 pi over n. And to find perimeter we need x, so let's find x, and let's consider, for example, a cosine rule, and it says that x squared is 1 squared plus 1 squared minus 2 multiplied by 1 and by cosine of 2 pi over n. And since we need the answer to be in terms of sine, we can simplify it, and it becomes 2 minus 2 times cosine. So we can factor out 2 firstly. 1 minus cosine over 2 multiplied by 1 minus cosine of 2 pi over n, and to get in terms of cosine, in terms of sine, we can apply double angle formula, and it says that cosine of 2 theta is 1 minus 2 sine squared theta. So it becomes 1 minus 2 times sine squared, but just pi over n, and it becomes 2 times 2 times sine squared of pi over n. Hence x is square root, so it's just 2 sine of pi over n, and the required perimeter becomes just multiply by n, so it's nx, and it becomes 2n sine of pi over n as required. E. Use an appropriate Maclaurin series expansion to find limit when n tends to infinity of p I of n, and interpret this result geometrically. 5 marks. So we should consider limit n tends to infinity over this p I of n, so it's limit n tends to infinity over 2n sine, and it is given that we should use the Maclaurin series for sine, and formula is given in the data booklet, and it says that sine x is x minus x cubed over 3 factorial plus x to the power 5 over 5 factorial, and so on. So it becomes limit to n multiplied by, we should use pi over n instead of x, it becomes pi over n minus pi cubed n cubed 3 factorial plus pi to the power 5 n to the power 5 multiplied by 5 factorial, and so on. And let's expand it and get 2 pi, limit of 2 pi minus pi cubed over n squared 3 factorial plus pi to the power of 5 over n to the power of 4 multiplied by 5 factorial, and so on. And we can see that there is 2 pi, and there are powers of n in the denominator, but when n tends to infinity, it means that n is very large, and if we divide by very large value, it's actually tends to 0, so it's actually limit is 0, and there is only 2 pi, and all other terms are equal to 0, so it's just 2 pi. And how to interpret this geometrically? So when n increases, this n-sided regular polygon just becomes a circle. So we can say the next, as n tends to infinity, polygon becomes a circle. And notice that we can see the polygon inscribed in a circle radius 1. So as n tends to infinity, a polygon becomes a circle of radius 1, and perimeter of this polygon, which is actually a circumference of a circle, is 2 pi. It's the circumference of a circle with radius 1. The next, consider an equilateral triangle ABC of side lengths x units circumscribed about the circle radius 1 unit and center O as shown in the following diagram. So now we should consider an equilateral triangle and a circle inside. Circle is inscribed, or triangle is circumscribed. So it is given A, B, C. Its radius of 1 and its side is equal to x. Let PC of n represent the perimeter of any n-sided regular polygon circumscribed about a circle of radius 1 unit. F shows that PC of n is 2n multiplied by tangent over pi of n for max. So we don't need to consider triangle only, we need to consider in general, and in general it looks like this: a circle inside and a polygon is circumscribed, and again we can consider one such triangle, and notice that radius is here, which is 1. Let it be m. And if we consider triangle AMO, it's a right angle triangle because radius is perpendicular to the tangent, and since a circle is inscribed or polygon is circumscribed, the circle touches a side at point M, and AB is a tangent to the circle which is at point M. So AOM angle is 90 degrees, and angle AOB, due to symmetry, it's it's 2 pi divided by n. So AOM is a half, because AOB it's an isosceles triangle. So AOM angle is just pi over n, and it's 1. And AB it's x, hence AM is x over 2. So AM is x over 2, and We can consider, for example, actually tangent. So tangent of pi over n, it's opposite x over 2 over adjacent one, and hence x is 2 times tangent pi over n, and the required perimeter is just nx, so it's 2n tangent pi over n as required. The next, by writing PC over n in the form 2 tangent of pi over n divided by 1 over n, find the limit n tends to infinity over this PC of n. So we need limit of this expression, and we should consider it as 2 tangent divided by 1 over n. It's the same, but now when n tends to infinity, it means n is very large. Pi divided by very large value, it's 0, so it becomes tangent of 0, which is 0, and 1 over n, it's also 0, so it's 0 over 0, so it's in indeterminate form, and it means that we can apply the L'Hopital's rule, and this limit becomes limit n tends to infinity derivative of the numerator divided by the derivative of the denominator. So derivative of a tangent is secant squared, but since it's a more complicated argument, we should apply chain rule, and it becomes tangent x in general derivative is secant squared, so it becomes secant squared and keeps the same argument pi over n, and multiplied by argument derivative pi over n derivative, and with respect to n it becomes pi is a constant, y over n derivative is n to negative 1, it's negative 1 n to negative 2, so it's negative 1 over n squared, and 1 over n derivative, it's n to negative 1, so it's negative 1 multiplied by n to negative 2, or divided by n squared, and it becomes limit n tends to infinity 2 pi secant squared of pi over n, it cancels, and what is secant? It's 1 over cosine, and again when n tends to infinity it becomes secant squared over 0, 1 over cosine squared of 0, cosine of 0 it's 1, so 1 squared 1, so it's secant squared becomes just 1, and finally just 2 pi, and the required limit is 2 pi. Then next, use the results for from part D and part F to determine an inequality for the value of pi in terms of n. 2 marks. So if we consider an inscribed polygon and circumscribed polygon, and we consider circle of radius 1, so this the circumference, which is 2 pi r in general, and the radius is 1, so it becomes 2 pi, and it will be greater than the perimeter of polygon inside, and it was this result. It's 2n sine of pi over n, so it's greater than 2n sine of pi over n and less than the perimeter of a circumscribed polygon, and it's this result 2n tangent of pi over n. And we can divide by 2 to get that pi is greater than n sine pi of pi over n and less than n multiplied by tangent of pi over n. And the next question, the inequality found in part H can be used to determine lower and upper bound approximations for the value of pi. Determine the least value for n such that the lower bound and upper bound approximations are both within 0.005 of pi. 3 marks. So it looks like this: pi, and it must be pi minus 0.005 and pi plus 0.005, and it's our lower bound, which is n sine pi over n, and our upper bound is n tangent pi of pi over n. So we can make the next inequalities. To be within 0.005 of pi, n sine of pi over n should be greater than pi minus 0.005, and n tangent of pi over n should be less than pi plus 0.005. And it will be more useful to rewrite as n sine pi over n minus pi plus 0.005 should be greater than 0, and n tangent pi of pi over n minus pi minus 0.005 is less than 0. It will be more useful to use the calculator, and we use the calculator, and we consider this function n sine minus pi plus 0.005, and it will be useful to consider just the table, and we need it should be positive, so we need the least positive value. So we consider the least positive value is 33, so the solution here is n is greater or equal than 33. And let's consider the second. So it's n tangent minus pi, but minus 0.005, and again just consider table, and we need the first negative value, and we can see that it's n is greater or equal than 46, but it's simultaneous inequalities, and we can see that the least possible value of n is 46. Determine the least value for n such that the lower bound and upper bound approximations are both within 0.005 of pi. So the answer is n is 46. And that's all for this question.